Earth's faster spin could lead to first ever negative leap second. Imagine this. Earth is spinning faster than usual, and it could lead to something unprecedented, a negative leap second. You might not have noticed, but our planet has been whirling at an accelerated pace in recent weeks, with some days being over 1 millisecond shorter than the standard 24 hours. But here's where it gets controversial. While this might seem like a minor detail, it has significant implications for technologies that rely on precise timekeeping, such as GPS navigation, telecommunications, and financial transactions. So what's causing this speed up, and why should we care? Let's dive in. Earth's days are rarely exactly 24 hours long. Various factors influence its rotation speed, including shifts in the Earth's core, changes in atmospheric pressure, ocean currents, and large-scale weather patterns like El Niño. Typically, these forces cause only minor fluctuations, but July and August have seen some remarkably short days. According to preliminary data from Time and Date, July 9 was approximately 1.23 milliseconds shorter than usual, while July 10 was 1.36 milliseconds shorter. July 22 is predicted to have been 1.34 milliseconds shorter, and August 5 is set to be 1.25 milliseconds shorter than a typical day. Among the many factors at play, the moon is the leading suspect. Its gravitational pull is a major driver of tidal forces on Earth, and these tidal interactions can shift the distribution of water and therefore mass across the planet, altering its spin. Currently, the moon is relatively far from Earth's equator, so its gravitational pull is marginally weaker. This eases the brakes and allows Earth to spin just a fraction faster. While variations of a millisecond might sound trivial, they are incredibly important to technologies that rely on ultra-precise timekeeping. If the trend of Earth's spin speeding up continues, it could raise the possibility of needing a negative leap second in the future to keep our atomic timekeeping in sync with astronomical time. Since 1972, international timekeepers have agreed to add a leap second every now and again to ensure our clocks are aligned with Earth's rotation speed as accurately as possible. This is because the general trend over the past century has been Earth's rotation slowing down, resulting in slightly longer days. Now, however, we are seeing Earth's rotation has upped its pace, resulting in slightly shorter days. As a result, a negative leap second might be needed to bring UTC back into alignment with astronomical time. In other words, timekeepers will subtract a single leap second to make sure the atomic clocks are in tune with the astronomical movement of our solar system. Scientists have discussed this issue for several years, with the suggestion that climate change and the rate of melting ice caps may mean we require a negative leap second in 2029. But the ongoing changes we've seen this summer could fire up the debate again. And this is the part most people miss. The implications of a negative leap second are not just technical. They could have far-reaching effects on global infrastructure and technology. However, leap seconds are not popular with everyone. Meta, Google, Amazon, Microsoft, and other tech companies have previously spoken against leap seconds, arguing they cause more problems than they solve. As an industry, we bump into problems whenever a leap second is introduced. And because it's such a rare event, it devastates the community every time it happens. With a growing demand for clock precision across all industries, the leap second is now causing more damage than good, resulting in disturbances and outages, Meta said in a 2022 blog post. Their concerns are not without precedent. In 2012, Reddit was struck with a major outage because the Linux operating system it was using failed to take into account the leap second. Since the idea of negative leap seconds is equally unpopular among the tech giants, and judging by the power and influence they wield, it seems unlikely they'll passively accept such a change. With the Earth's rotation pattern changing, it's very likely that we will get a negative leap second at some point in the future, Meta said. The impact of a negative leap second has never been tested on a large scale. It could have a devastating effect on the software relying on timers or schedulers. So what do you think? Should we embrace the negative leap second as a necessary adjustment to keep our timekeeping accurate? Or is it a risky move that could disrupt global technology? Let us know your thoughts in the comments below. Why Earth is spinning faster? The science behind the second shortest day in history. Earth's rotation is mysteriously speeding up, and scientists are puzzled. In a fascinating twist that's leaving scientists scratching their heads, our planet is about to experience one of its shortest days in recorded history. Today, July 22nd, Earth will complete its daily rotation 1.34 milliseconds faster than normal, a tiny difference that signals a perplexing shift in our planet's behavior. But here's where things get really interesting. This isn't just a one-time anomaly. We're witnessing a mysterious trend that could force us to do something unprecedented by 2029. Remove a second from our atomic clocks, a negative leap second that's never been necessary before. To understand why this is so remarkable, let's dive into Earth's rotational history. Believe it or not, our 24-hour day hasn't always been a standard. Early in Earth's history, a day lasted only about 19 hours, according to groundbreaking research published in 2023. Over millions of years, our days gradually lengthened, primarily due to the moon's gravitational influence. As our celestial companion slowly drifts away from Earth, it pulls on our planet's oceans, creating tidal friction that typically slows Earth's rotation. But here's where the mystery deepens. Since 2020, Earth has been breaking speed records. The fastest rotation ever recorded happened on July 5th, 2024, shaving off 1.66 milliseconds from our usual 24 hours. Today's shortened rotation will make it the second fastest day of 2025, with another speedy day predicted for August 5th. What's causing this unexpected acceleration? That's the billion-dollar question that's sparking debate in the scientific community. While some researchers point to melting polar ice and rising sea levels as potential factors, these environmental changes might actually be moderating the speed up rather than causing it. The more compelling explanation, though still controversial, lies deep beneath our feet. Dr. Leonid Sotov, a prominent Earth rotation expert from Moscow State University, suggests the answer might be found in Earth's liquid core. Changes in how this molten heart of our planet moves could be redistributing angular momentum, essentially giving Earth's outer layers a temporary speed boost. But here's the twist. This acceleration might not last. The rate of speed increase appears to be slowing down, and some scientists predict we might soon return to the long-term trend of gradually longer days. This raises an intriguing question. Are we witnessing a temporary blip in Earth's rotational behavior? Or is this the beginning of a new pattern we don't yet understand? What do you think could be causing these mysterious changes in Earth's rotation? Are we overlooking something obvious? Or is this truly one of our planet's greatest current mysteries? Share your theories in the comments. The scientific community is still debating this phenomenon, and fresh perspectives could lead to new insights. This story continues to evolve as new data comes in, and it's a perfect example of how Earth can still surprise us with unexpected behaviors, even in an age when we think we understand our planet so well. Keep watching this space for updates as scientists work to unravel this fascinating planetary puzzle. Earth's spin speeds up, uncovering the shortest days in recorded history. Hey there, curious minds. Ever thought about how the length of a day could change? Well, here's a twist. This summer might be giving us the shortest days in recorded history by a hair's breadth. But here's where it gets controversial. While we're basking in summer's glow, scientists are scratching their heads over why Earth is spinning faster than ever. Let's dive into the science behind this cosmic clockwork and why even a millisecond matters. Imagine a world where each day is a fraction of a second shorter than the last. Sounds impossible? Yet, on July 9th, Earth completed a full rotation 1.34 milliseconds quicker than the standard 24-hour mark. The International Earth Rotation and Reference System Service, IERS, and the U.S. Naval Observatory confirmed this, and they predict two more record-breaking days this summer, July 22nd and August 5th. But what's causing this sudden sprint? The moon's gravitational dance plays a role. When it hovers near the equator, it slows Earth's spin, but when it drifts toward the poles, it gives our planet a nudge. Then there's the atmosphere. Summer jet streams slow the air's rotation, forcing Earth to compensate by spinning faster to keep angular momentum balanced. And here's the part most people miss. Earth's molten core has been decelerating for 50 years, making the solid Earth above spin faster to maintain equilibrium. Geophysicist Duncan Agnew admits, we don't know why or what the core might do in the future. Are these truly the shortest days ever? Not quite. Fossilized coral and mollusk shells from 430 million years ago reveal days as short as 21 hours. But since the moon's tidal forces have been gradually slowing Earth's rotation for billions of years, the recent millisecond fluctuations are just blips in a cosmic timeline. Still, the IERS notes that days in 2022 and 2024 were already shorter than those in the 1820s. You might not notice a 1 millisecond difference. After all, a blink takes 100 to 400 milliseconds. But for astronomers and tech systems, it's a big deal. Atomic clocks, which tick at a constant rate, now lag behind Earth's erratic spin. To fix this, timekeepers add leap seconds, extra seconds to realign atomic and astronomical time. But here's the kicker. If Earth keeps speeding up, we might face the first ever negative leap second by 2029, which could crash software expecting time to always move forward. Meta engineers warn this could devastate systems reliant on precise timing. And this is the part most people miss. Climate change is also playing a role. Melting ice, rising seas, and groundwater depletion are redistributing Earth's mass, slowing its spin like a skier extending their arms. Yet, the core's slowdown and atmospheric shifts are counteracting this. Astronomer Nicholas Stamatakis admits, predicting day lengths beyond 6 months is impossible due to these tangled factors. So, will you feel the difference? Probably not. But the next time you check your watch, remember, Earth's rotation is a cosmic tug-of-war between the moon, atmosphere, and deep Earth forces. And as for the future, well, the sun will keep rising. But how long each day lasts? That's a mystery even scientists can't solve. What do you think? Should we panic over a millisecond? Or is this just nature's way of keeping things interesting? Drop your thoughts below.